Hi Gators, I hope you guys are having a beautiful day. We miss you guys tons. So to pick up where we left off, in this chapter we've been solving a lot of problems with area and perimeter. Remember, area is a measurement of how much space a plane shape takes up on the inside, and perimeter is a measure of how long that shape is along the outside. We've been practicing with mostly rectangles, but some different polygons or sided shapes. And today we're going to continue with that as we solve for the area of something called combined rectangles. So I'm going to start us off by asking, what is a combined rectangle? Well, it's a lot like what it sounds like. So a combined rectangle is a polygon or a sided shape that looks like two or more rectangles stuck or combined together. And I have an example here for you. So this is a combined rectangle. It looks kind of like somebody combined two rectangles. So maybe you see this rectangle and this one added onto it. Maybe you see one here with another one added onto it, but it looks kind of like somebody took two rectangles and stuck them together. Now, this combined rectangle and many of the ones we're gonna see today are gonna have unit squares to help us solve for the area. So that's a great way to go ahead and check your answers for your area today. But I really encourage you to be using your area model knowledge to help you solve for the area of these shapes. And here's why. These shapes will not always give us the unit squares. Sometimes they will just give us the side lengths, and we will have to figure out the area. So with that in mind, today we're going to learn how we can cut or uncombine these two rectangles and use that to find the area of the whole shape. So the first step is to go ahead and cut apart these two rectangles or uncombine them. Now, like I said, there's two different ways maybe you could do this. Maybe you see this rectangle as being a main one, and then this is kind of the side one, or maybe you see this as being the main one and this one's kind of stuck on. It doesn't matter how you want to separate these two rectangles. You can do it in whichever way is easiest for you. So just to show, I'm going to go ahead and cut my rectangle right there. Remember, I could have cut it differently. But now I've made two rectangles. So now I've made a rectangle 1 up here and a rectangle 2 down here. All right, so now that they're actually rectangles, I can use what we know about arrays and area models to help me solve this much quicker than actually counting out all those squares. So I see that the side length here is 3 units. And I see that this side length is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 9 units. All right, let's look at our second rectangle. Our second rectangle has a side length of 2 units, and this base is 4 units. Now I can solve for the area of those two rectangles by multiplying the lengths and the widths. So rectangle 1's area would be 3 units times 9 units. And if you know your 9's trick, you know that that would be 27 square units, or units squared, right? Now we're ready to solve rectangle 2. So rectangle 2 has a side length of 2 and a base of 4. So I'm going to go ahead and multiply 2 and 4. And 2 times 4 would be 8 square units. All right. So I know that if I counted all these squares, I would get 27. So this is 27 square units. And I know that if I counted all the squares in here, I would find 8 square units. So now if I told you what's the area of this whole shape, how do you think you could do that? Well, we took our rectangles apart. Now it's time to put them back together. So we're going to add this 27 to this 8 units to find the total area of this shape. So I'm going to go ahead over here and write my 27. I'm going to add my 8. 7 plus 8 would be 15. I'm going to carry my 10 to the 10 spot and put my 1s underneath. And 2 and 1 makes 3 10s. So my total area would be 35 square units, or 35 units squared. All right, ready to practice some more problems? Today, they are also going to give you problems that show you how the distributive property lets you do this, lets you just cut rectangles. So remember, the distributive property tells us that a large equation, or in this case, a shape, can be broken into smaller pieces. And it's called the distributive property because one side usually stays the same. That's just the nature of making one cut, right? Either this side's gonna stay the same when I cut it this way, or this side's gonna stay the same when I cut it this way. And so that number will be in both equations, or distributed to both equations. All right, so I have a rectangle here. You can see that it has 4 units as its width, and it has 8 units as its length. And I've already cut this. So I cut it right down the middle. I could have cut it anywhere I want, but that's where I cut it. And so I had 4 units by 4 units, and this one is 4 units by 4 units. So I actually made 2 squares. So now we can solve. The area of this shape right here, this square or piece, is 4 times 4. And then I'm gonna add it to the area of this piece, which would be 4 times 4. So 4 times 4 plus 4 times 4 will give us the total area. Are you with me? So if I solve for the area of this and I add it to the area of this, I'm kind of putting them back together. All I'm doing is making a smaller problem for me than 4 times 8. So I changed 4 times 8 into 4 times 4 plus 4 times 4. All right, so now we can solve. 4 times 4 is 16. And then I know that 4 times 4 is 16 because I just solved it. 16 plus 16, or 16 doubled, will be 32. And I can't forget to put square units, or units squared. Right, friends? Always put your units. All right, now I want to show you, just like we did with arrays when we learned our distributive property, that it really doesn't matter where you cut your rectangle. With combined rectangles, you always want to make sure that you cut it in a way that creates rectangles. But if they give you a regular rectangle, like they did here, you are welcome to cut it any way horizontally or vertically that works best for you. So just to show, I'm going to go ahead and cut it right here. So if I cut it there, and I'm going to ignore my orange mark, I now have a 1 by 8 on top and a 3 by 8 on the bottom. So I can find that area of the whole shape using those 2 smaller rectangles. So I have 1 times 8 for the 1, the top rectangle that I cut off, and I would have 3 by 8 for the bottom. All right, so 1 times 8 would be 8. So that's the area of this top section. And I'm going to add that to 3 times 8, which would be 24. And that would be the area of this whole bottom section with the new way I've cut it. All right, so I would add 8 to 24, and I would still get 32 square units, or units squared. So it does not matter where I cut my problem, how I decide to make those pieces smaller. Either way, it helps me find the area of the whole shape because the shape itself did not change. All right, friends, so you're gonna see some of these problems today. You're also gonna see some combined area problems. So now it's time to go ahead and grab a sheet and practice along with me. Please pause this video at any time if I'm not going at a speed that works best for you. I also encourage you to go ahead and check your answer. So if you pause and you're not sure about whether your answer is correct, go ahead and count those unit squares to double check that you're using these methods correctly. All right, Gators? So let's go ahead and dive in. First, I'm going to show you some examples of distributive property problems. So they're going to give you a regular rectangle, and I've given you one here. So it's 5 feet by 9 feet. So our width is 5 feet, our length is 9 feet. And I could count those squares and find it to be true. So go ahead and pause if you want to write down those dimensions or draw in your unit squares. All right, Gators. So now it's time to cut. So remember, we can cut any way we want as long as it's vertical or horizontal. It wouldn't make sense to cut it diagonal because then we'd have all these weird little triangles that we can't really count, right? So I'm gonna go ahead and just cut it, I don't know, here. And if you cut it somewhere else, that's okay because we're gonna check to see if we both got the same answer and we're gonna prove the distributive property works. All right, so with my cut, I end up with a 5 by 1, 2, 3, 4, 5, which is nice, right? 5 times 5. So I'm going to go ahead and write that in. To find the area of this square, this section of the rectangle, I multiply my length and my width, 5 by 5. This one is going to have a side length of 4 and a side length of 5. So to find this section of my rectangle, I'm going to multiply 4 times 5. And we're going to see that when we put them back together, we find the area of the total shape, right? So if I had to do 5 times 5, 5, 10, 15, 20, 25. So the area of this section would be 25 squared units, or units squared, in this case, feet, right? And now let's solve our second section. Our second section would be 4 times 5, so 5, 10, 15, 20. So I have 20 feet squared in this section. And if you counted those squares, you would find that to be true. All right, so now I'm ready to put them back together to find the area of the whole rectangle. So 20 plus 25, that's the same as saying I need 2 more 10s on this 25. So 25 plus another 10 would be 35, and plus the second 10 would be 45. So my area for this total rectangle, which we solved using distributive property, is 25 feet squared, or 25 squared feet. All right, Gators? So I'm going to go ahead and show you a combined rectangle problem, and we're going to use our cutting method to help us solve. All right, so here's the shape. If you want to take a moment, pause the video, and write down those dimensions. You can see already that it looks like more than 2 rectangles this time. You might see a rectangle here, here, and this middle section. Maybe you see the middle section as being one long rectangle with 2 smaller ones added on. Like I said, there's multiple ways to cut. You could even make this a long one and then make this go this way and have a short one here. But the real question is, are we gonna end up with that same area? And the answer is yes. All right, so you should have had time to pause the video and go ahead and make this shape on your own paper. First, we're going to section this off, or uncombine these rectangles. So like I said, this time there's 3. So you can cut this in the way that's easiest for you, but I'm gonna go ahead and cut straight down here and straight down here, and leave myself with rectangle 1 here, rectangle 2 here, and rectangle 3 over here. So I have 1 rectangle, 2 rectangles, 3 rectangles. So you could see that this rectangle over here, rectangle 1, has a side length of 4 units and another side of 3. Rectangle 2 has a side length of 2 units and a length of 4 units. This third rectangle has a side length of 2 and a length of 4 units. So we're ready to start solving for our area. So rectangle 1, we said, was 4 and 3. So rather than counting those squares, I'm going to multiply, right? And I'm going to say 4 times 3 is 12 units squared, or squared units. You can write it either way. The area of rectangle 2 is 2 times 4, which would be 8 units squared, or squared units. And rectangle 3 is 2 times 4 again, just moved on its side. So knowing my commutative property, I know that that is also 8 units squared, or 8 square units. All right, so this is awesome. We found out that the area of this section would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Checking my math, 12 square units. We know that this section would be 2, 4, 6, 8 square units. And this section would be 2, 4, 6, 8 square units. But they don't want to know just the area of these 3 separate rectangles that we made. They want to know the area of the total combined rectangles. So to find that, again, remember, we're putting these numbers together or adding them up, right? Just like we add up the squares when we count them. So I'm going to add 12 plus 8 plus 8. All right, and I know 8 and 8 is 16. So I'm gonna go ahead and cross this out, and I'm just gonna add to 12 my 16. So 6 plus 2 would be 8 ones, and a 10 and a 10 makes 2 10s, or 20. So my answer would be 28 units squared, or 28 square units for this whole combined rectangle. And like I said, it's a great practice when they give you these unit squares to go ahead and check your answer through counting, but you should be practicing it by multiplying those side lengths. So really quick, let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And I've checked my math. We are correct. All right, Gators? Please go ahead and watch this video again. If you have any questions, reach out to your teacher. We're so happy to help you. We miss you so much. Have a great day, Gators. Bye.